this morning. And also thank you to John as well and the Astral team for the introduction. It's just fun to find other folks out here working on similar technologies. So to start, just a quick bit of background about me. I've been in crypto since 2018, spent a number of years at TokenSoft, where we were essentially a compliance and launch partner. We did the first IPO on chain. That's IPO, not ICO. And so I've seen a lot of things in the crypto space and just wanted to build something that was like fundamentally real. And so to start with, I put sort of a provocative quote here. Imagine this as a journal entry from the year 2039, just to give you an idea of the vibes where we have as we approach this project. And it's based on, I'd say, like some pretty hardcore optimism, right? Like if you fast forward 10 or 15 years, I think we are going to see a lot more things in space as well as on Mars. We're going to see a lot more connected devices, like covering the Earth and the space around it, like the Starlink constellation, which is beautiful. We're going to see more robots, more autonomous vehicles, and things like that. Okay, so that's like a really interesting trend to take advantage of. But we also, we're realists at Proximum, me and my co-founder Noah, and we see that there's also a lot of fundamental problems on the internet. So I'll dive into those problems in a second, but I want to start with a basic definition of what Proximum is. In short, it's an open protocol proving the location of any device on chain. So open protocol as opposed to a closed system like Apple AirTags, those are wonderful. If I've lost my iPod, like very good way to prove it, but it's not like a public open thing that any device or system can plug into. Proving location as opposed to measuring it, again, like differential GPS, RTK GPS, there's a lot of great techniques for measuring location. We think one of the primitives that's missing is the ability to actually prove it in a way that like neutral third parties who don't necessarily trust your assertions on face value can then verify, like, okay, this is real. Of any device, because what we're doing is based on fundamental physics and math, it's essentially agnostic as to what kind of devices you're using. And I know, Taylor, we talked about the folks at Foam and the system they're building. Have they been on here yet?
Yeah. So, you mean today or in general?
Just in one of the previous talks.
Yeah. So we had Ryan talk a bit about foam previously, and
Okay,
I
perfect.
don't see them on the call now, but they may join.
Okay, yeah, super awesome work they're doing. I'd say like the contrast with Proximum is we're not doing custom radios or like specific stuff. We're just aiming to make it kind of device agnostic. And then finally on chain, this is a decentralized group. Proximum is a decentralized protocol. The things we're building, we aim to make them compatible with like general crypto networks. So why does any of this matter? Fundamentally, we believe it's because it's pretty easy to lie on the internet, right? And so that's like a single problem that shows up in a couple different contexts. We've got fake content, right? Of course, with generative AI, that's now easier to make. We've got adversarial counterparties. Often there are big financial incentives to like misrepresent where something is. Like in advertising alone, that's like $84 billion a year. That's lost often due to misrepresenting where the people viewing the ads are. And then in crypto itself, I think a lot of us here are probably, we really believe in this ecosystem. We really believe that decentralization is important, but there's probably some work left to do in like actually getting real decentralization. Even the big protocols like Bitcoin and Ethereum have these like fairly subtle centralizing forces that we have to remain vigilant against. Okay, so how do we solve these problems? Kind of the big thesis here is what we want what we want Proximum to do is to tether cyberspace to space-time. So what does that mean? Like, let's assume for a minute that that's possible. Well, we have basically a new authenticity layer where whether it's media, devices, IoT things, shipments, whatever, like we can actually generate a cryptographic proof of where that thing is. Second, we can do essentially real geofencing, whether on or off chain, in a way that's resistant to VPNs. And so we'll talk in a little bit about some of the applications for that, but basically real digital fences. And then finally, like if you had to choose one axis along which to measure true decentralization, it's probably physical separation. Like if you imagine a network that covers the Earth and then it kind of blankets space-time around Earth, throughout the solar system, let's be real optimists here and assume it gets to Mars. Like that's a very decentralized system. just objectively. And then there's a lot of like economic or political forces that traditional crypto networks might be subjected to that this would just be resilient against. So those are the things we're aiming to do with Proximum. I think like the immediate next question is like, okay, well, that all sounds very nice. How does it work? And to be clear, like this is a protocol still in development. We're working on launching our testnet later this year. And so by all means, like jump in with all the questions and critiques possible. So to begin, like as I mentioned, it's device and channel agnostic. Like there aren't any trusted parties here. So we're not using secure elements. We're not using GPS reference positions or anything like that. We're just basing this on physics, like the speed of light, math, and then a little bit of crypto economic incentives. So the intuition's like pretty straightforward. I'm out here in Salt Lake City at a crypto conference, permissionless. Let's say I wanted to prove to Proximum that I was in Salt Lake City. So I'd send a transaction to the network. It would randomly select 10 nearby beacons, and then I would send messages to them. Well, first they'd sign and send a message to me, then I'd sign and send it back. And the intuition there is they can look at the time that it took for that message to get from them to me and then from me back to them. And that puts an absolute upper bound on the distance between our key pairs. Like, so that's a trustless way to measure proximity because they can just look at that time elapsed and compare it to the speed of light and say, like, look, like we know that this key pair is within, say, 100 kilometers of us. So you do the same thing with a series of beacons in various directions, randomly selected, and then you use like an extended Kalman filter or a least squares method, essentially to look at where those circles overlap, and then turn the overlapping of those circles into an estimated position. Then what you do is you generate a ZK proof of that computation. So whether it's the least squares computation or the extended Kalman filter. And so now I have like a concise, portable cryptographic representation of where the Proximum network thinks that my key pair is. And so like, let's say, let's say there was an NFT getting minted for all attendees of this conference. Like then I could go on maybe the Ethereum blockchain, I could send a transaction in, and then I could provide this as a proof like, hey, I have a cryptographic proof. Don't just take my word for it. I am indeed in Salt Lake City. Like, and now I have gained access to mint that NFT. So any questions so far on kind of the fundamentals or how this works? Yeah, John.
Yeah, just one question. So the main thing that I am not quite clear on with the trustless clock, right? The recursive hash depends on the clock speed of the processor, right?
Yep.
So how are you able to create some sort of verifiable evidence that this processor was processing this hashing algorithm at this rate?
Yeah, so I mean, basically, we just have to bound it. So like Solana has a somewhat similar problem, and I think they set it at like what 300,000 hashes a second. There's like just a canonical number they set, and they said like, look, this is what we think like reasonably good hardware will be able to do. So it provides a rough timestamp, and like yes, there are exceptions. So if you have like a 4 gigahertz CPU and you put it in liquid nitrogen, your clock is going to be a bit faster. And so there are ways that like some beacons are going to be able to cheat that a little bit, but it's a matter of degree. Right? And so like the key thing there is you only are relying on that clock during that ping and that pong process. So like it's not as though you can like put your CPU in liquid nitrogen and then fast forward a year. It's going to be on the order of milliseconds still. Got it. Any other questions on the basics? I want to show you something that we've been working on. This is going to be in the next version of the light paper that comes out. But one of the things we've been thinking through is how to minimize the trust assumptions. Because in that basic measurement process we just described, like you can imagine some adversarial beacons. Like maybe a good number of the beacons around Salt Lake City are actually deceptive, right? And they're just lying about the distance that they measured to my key pair. So one of the things we can do is rather than just doing these point-to-point measurements, we can do cycles of measurements. And so then if you imagine a cycle where like the signature starts with one beacon and then it goes through the key pair being measured and then it goes through a series of other beacons, you can basically look at the latency tau here required for the message to get back to the original part of the cycle, the original beacon. And that gives you like causal bounds on the position of all the nodes in the cycle, or all the beacons in the cycle. And so that's one of the changes we're working on to the protocol, is rather than having sort of like a naive N of N honesty, where like any dishonest beacon could try to like disrupt or deceive about the location of the key pair being measured. We want it to be as close as possible to like 1 of N honesty, where like all the parties can essentially cross-check their relative positions and ensure that they're representing the positions of all the beacons accurately. Now, of course, this is a crypto protocol, so you can use slashing to avoid that. But as much as possible, we want this to be based on just math and physics rather than crypto economic incentives. And so thinking about this as a crypto protocol, just like a Helium or a Foam or these other deep-in style networks, there's a token. Beacons earn that token for being available for location services, essentially proof of coverage. And then the users who want to prove their location are paying in the token. So the supply side there, like we can start with like basic commodity hardware, whether it's UDP or TCP packets. Like one of the common critiques we get, and we think it's a really good one, is like, look, network topology doesn't really map to spacetime, right? Like we might be sitting next to each other in a coffee shop, and if I try to send a message to you over the internet, it might be routing through some completely different city. And so that like puts fundamental limits on how accurate the network can be at the beginning when we're launching with commodity devices. But then if you think through like how connectivity is progressing, like the fact that we have Starlink satellite constellations now, and we have Bluetooth Low Energy and ultra wideband on our phones, like the ability to do point-to-point communications is increasing rapidly. And once you go point-to-point, like that network topology problem goes away, like you're back to the land of physics, where you're looking at the radio propagation, and that's like 99.9% the speed of light. So that's essentially Proximum. Like the leap of faith here in the crypto economics is if you create the correct incentive structures, like large numbers of people with existing devices will bring them on in the form of beacons because they can earn tokens for doing it, and then they will provide those location services. So on the demand side, and I'd love to cover this in the Q&A, kind of how you all think about demand side and where location proofs and these location services are really getting picked up. We see a couple interesting opportunities. So I think what they all have in common is there's some sort of an adversarial relationship between the parties involved. So in cybersecurity, of course, like you have attackers, they're trying to get into your system. And so you can imagine sort of like a low CAPTCHA, like a reCAPTCHA that's location specific, where if you want to defend Web 2 or Web 3 systems from attackers, you can demand that the user submits a low CAPTCHA generated in their browser with Proximum. And then if you can essentially geofence where your valid users are, you'll be able to cut down on your attack surface by preventing folks from outside that region from getting in. Another one, this one's sort of far out there, but on the defense side, we've seen actually some conversations about the non-proliferation of AI hardware, where cutting edge like NVIDIA chips and things like this are starting to be in the realm of like geopolitical importance. And so you can imagine devices, whether it's hardware chips or it's drones or other military equipment that are geofenced, where regardless of who's actually running the device, the thing is measuring its location with Proximum, and it's only like fulfilling or unlocking certain capabilities if it's within a specific geofenced region. So on the more like practical day-to-day side, we see a lot of applications in authenticity. So deep-in sensor networks are a pretty clear one, where hey, if you're measuring the air quality in Dubai, like your network is probably going to live or die by the quality and reliability of that data. It's probably good to have like a third-party neutral reference check that air quality sensor is in Dubai. There may be some other things on insurance and commerce. And looking forward long term, like one of the interesting things we see is I think in crypto, this is, and please, someone let me know if they've seen this elsewhere. I don't think we've explored locality enough as a scaling mechanism. So you can imagine local subnetworks built on top of a base universal or global network. And then once you've defined a local network, the latency inside that local network can get a lot better. So as an analogy, think of high frequency trading that the folks do out near New York or Manhattan. Like they have to co-locate because they can't get around the latency issues, right? Like light takes about 67 milliseconds to go around the Earth to the other side. And so for many applications, like a kind of global consensus mechanism is just too slow. So we think that spatial subnets could be a pretty interesting application. And then the other one is physics-based security. As I mentioned, like our thesis is that physical separation is like the best, simple, straightforward measure of true decentralization. And so that means Proximum can be used to audit other devices, other protocols, and ensure that they are actually decentralized. It also could become sort of its own modular security mechanism, where if you have some form of computer consensus, some protocol where you want to like buy into some existing security, maybe there's a way to build that on top of Proximum. So what are we up to right now? So one of the things I mentioned the team is doing is we are working towards building the testnet. The first step in that is this testnet simulation. It's all public and open source, so feel free to take a look at it. Essentially what we wanted to check, just do a reality check for our own sakes, was whether or not this was resilient to adversarial attackers. And like the good news is, in general, extended Kalman filters, least squares methods, they're pretty resilient to attacks like this. And so even in a situation where everyone's misrepresenting their location by like over 1,000 kilometers, like these algorithms understand where that noise is coming from, they filter it out, and they do a better job of estimating where nodes actually are. So long-term endgame here, like I think we can get under 100 kilometers for the initial network. And then if you think about like the resolution limits that physics provides, like ultra wideband is basically pushing physics to its limit, right? With like these very precise spikes of electromagnetic energy that let you measure distances extremely accurately. And that's well under a meter. So like, I don't think Proximum is going to ever get to sub-meter accuracy, but I think there's essentially plenty of room at the bottom to increase accuracy as the network matures. Spatial subnets, I talked about this briefly, but I think this long-term could be like a very interesting underexplored mechanism. One of the things I think would be very fun to build on top of this, like this is not Proximum per se, this is just something I hope somebody does. I've talked to some of the folks who used to be at Cello and they've considered similar things, is if you imagine, right, so during periods of economic crises, people usually are often resort to local currencies that they sort of make up in an act of desperation. And we saw this during the Great Depression. There were a number of cities that did this. So if you imagine a currency that's locally bounded, or it's restricted, so it must operate only within specific geographic boundaries, then it may be possible to tether that currency like a flat coin more accurately to local economic conditions. And so the way you would do that is you would geofence this thing, and then you could use like a Uniswap v4 style exchange mechanism as value flows into and out of that region. And then what that would give you is essentially a trustless measure of the flow of capital into or out of that region, which you could then use to essentially inform a trustless central bank policy as to what interest rates should be inside the region. So this is like a pretty far out there project. I think it would be wonderful to see someone build that using proofs of location. I think that in general in crypto, like location is just, it's not a very well explored axis. And I think whether it's proofs of location or locally bounded currencies, I think there's just a lot of room to explore. So that's Proximum in a nutshell. Most of what we're doing is extremely open, MIT licensed, public white paper, public code. So I would love folks check it out, and by all means, like happy to take any questions.
So somebody had asked if it was similar to DKSG, distributed keygen. I don't know if that's a question that they wanted to field, but
it might be, but I'm not familiar with DKSG.
Hey, my name is Santos, and I'm here specifically just to hear about the approach that you're taking, and just to know for decentralized proof of location. Have you guys looked into like what foam space their team is doing and how your approach fundamentally differs from there, and then some kind of trade-offs that you can shed some light on, that would be wonderful.
Yeah, for sure. So the foam team is great. Met up with Ryan and a couple other folks out in Austin recently, and like I've seen the radio that they're building, like really cool device. And in my previous startup, I did like 3D printing hardware, so I understand like some of the challenges they're facing with custom hardware. Like it's really hard to build hardware. So and the funny thing is talking to them, they're actually using an extended Kalman filter as well. So it's like a very similar idea there that like, hey, we have like well-defined, good mathematical techniques to improve the resolution of distance measurements. So I'd say like in terms of how we look at foam, like friendly, talking to John at Astral, like we think there are going to be many different types of location proof that exist on chain, whether it's from foam or Proximum or like a GeoNet, like a differential GPS measurement. Like we think that in general, we're going to need like uniform ways to handle these various types of location proof, regardless of how they're generated in like a uniform way. So that if you're building like a DeFi contract and location is a key part of that, you have like a uniform way to engage with it. So I'd say in general, we're friendly with them. The key difference here is we are sacrificing initial accuracy to enable Proximum to work on any device, right? And so that's like a really big difference in philosophy, that we're willing to take that loss in initial accuracy, but it means that like any internet connected device you have should be able to participate in this network.
So is it a true statement to say that it doesn't require any custom hardware equipment?
Exactly.
So it's all software based then, right?
Exactly.
Cool. Thanks.
Yeah.
Nice presentation.
Yeah. And like thinking about where this will go, right? Like if you take the leap of faith and you say, look, crypto economic incentives are actually pretty good at building out the supply side of global networks like this. And like that's something we've seen with Helium, which did have custom hardware, and a number of other networks. Then long term, like what is the equivalent of an ASIC? Like what is like Taylor custom made hardware look like that serves this purpose really well? It's essentially point to point, low latency devices. And so, like I mentioned, there's a number of those that exist already, whether it's Bluetooth on your phone, Starlink satellites, or other satellite constellations. But long term, like that's how typically I think crypto networks tend to progress. Is that like the mining or the beacons in our case, that kind of service tends to be professionalized. And so 5 or 10 years out, it tends not to be like generic hobbyists doing this. It's people who have economies of scale and professional dedication to like building these low latency networks. So that's the kind of thing that we wouldn't be surprised to see develop as the network matures.
I think the advantage that foam team has is I think maybe something that comes with the hardware or they have developed in-house basically after years of experience or research is software in some sense can still have some space that can be spoofed. And I think they are completely abstracting that hard software layer at all.
Yeah, as in they're treating their beacons or whatever they call their nodes essentially as a trusted device where they have like a secure element in it. Or what do you mean by that?
So I think, yep. So basically they are relying on their zone anchors and
Yep, zone anchors, yeah.
yeah.
Yep, and I think that's a good thing to clarify is we've taken a different approach there as well, is we don't want to depend on any trusted parties or anyone where we say like, look, we trust you guys, like we have a trusted element in here. Folks know I'm like notoriously cynical about things like SGX. And I think in general, like if you have like a little box with something valuable in it, people find a way to get into the box.
But certainly
So
good to hear from your approach, and certainly we need
yeah.
multiple approaches, just to work complementary.
Yeah, exactly. And
Yes.
like that's where I think the space will go, is like there are going to be multiple ways to solve this problem. John, I see you have a hand raised.
Yeah, well, I think to that point, Santosh, on the complementary approaches to proving location, this is something that we've thought a lot about at Astral. And I think if you take the example of foam and Proximum, right? Foam I think of as a local kind of localization network, right? You have this little area of trust zones that is able to provide quite precise hardware-based triangulation of positions. And something that Proximum, the way I conceptualize it, could offer is a more of a global kind of reference system almost to say, all right, we know this is a trust zone deployed in New York, but how do we know actually where exactly these trust anchors are on the global grid, for example? And Proximum could say, hey, I can tell you you're within a meter of this particular location and help you kind of lock in the position of that trust zone. So yeah, I mean, I think it, and I guess also just to say, one thing that Chris kind of said early on, I think even in the white paper, is the the speed of light can't be spoofed, right? Like that seems to me like the one of the key insights here is that especially once you get to those direct line of sight links, that becomes really, really hard to mess with. But yeah, Chris, I really love this. I know we've been talking for a little while now. I think the applications you're thinking through are really fascinating. I've thought through, like, it's really exciting to hear because I've thought about a bunch of these ideas as well. And I'm curious if you've kind of how far you've gone down that, thinking through exactly how those systems using location as geofences or, local currencies. Have you thought much about how that would technically be implemented? I know obviously if we have really credible location proof, that's one really key piece of the puzzle, but there's a lot of stuff that it would take to really build those systems and get them deployed. And I'd love to hear your thinking on that. And I think it is the start of a deeper conversation we can have offline of some of the ways we've been thinking about it at Astral.
Yeah, well, I mean, the right answer is like we're just going to make Astral solve that, and we'll we'll give you the data, and you can standardize it. But in seriousness, like the way we're looking at launching Proximum is on top of Solana, and the main reason for that, is I'm kind of an EVM guy by default, but a lot of the deepins are on Solana, and so for us, it's like being close to customers is just really important. And so the way you can think about this is the Proximum protocol has a set of asserted locations, right, backed by economic stake through a token that all the beacons have. And so then when I come in and I like do a Proximum transaction and I ask for location proof, then the participating beacons like give me their distance measurements. So now I have a series of like 10 signatures from 10 beacons with 10 distances. And then I, the end user, I roll that up into a ZK proof. And so then I drop it into Proximum and I say, hey, here's the ZK proof. Like it validates it. And then as long as everything checks out, now my asserted and proven location is condensed down to a Merkle root. So I can say like, look, there's a root Proximum state. It's this like 32 byte hash or whatever. And that is where things are. So then if I want to use, and so some of this I'm going to be kind of hand wavy on because we haven't done the bridging yet. Like that's like a future problem. If I want to use that like within Solana, like okay, pretty straightforward. Like I can just say like, hey, here's my key pair, here's my ID. Look, here's the proof. I'm in the Merkle root with this location. For cross-chain applications, where let's say this is on an EVM network, maybe they're bridging over to like reference that Merkle root. Maybe they're dropping in that ZK proof itself to say like, look, you know that these are 10 Proximum beacons. Like, here's the math. They just proved that I'm within like 3 kilometers of this location. So I'd say TBD on like exactly what's in the byte string. But at the end of the day, it's going to look like a byte string that you drop in to any smart contract. And so like, let's say you're a DeFi protocol and you're trying to use this, right? You shouldn't have to understand the inner workings of Proximum. You should just know, like, here's a reference contract address, like just call this method on this contract, provide this byte string and this like reference location. And then as long as that checks out, like you'll get a Boolean yes, like this is good to go. If it doesn't check out, you'll get a no. And so for those like looking at implementing Proximum for their use case, like we should be able to make it like extremely straightforward to use, even if there's a lot of like complex math under the hood.
Yeah, and that makes sense. And I think one of the lines of research we've been working on at Astral is what we're now sort of branding as on-chain GIS. How do you have a geospatial database that's stored in smart contracts and then have a suite of geospatial algorithms at your disposal to say, hey, I want to test if this point is inside of this polygon. If it
Yeah.
is, they get this local exchange rate. If it's not, they pay a different rate, or they're not allowed to spend it, or they pass this fraud check, or whatever it might be. We think that's going to be a huge unlock. And, obviously irregular polygons is a trick, but H3 buckets, bounding boxes, those are real easy to implement even in Solidity. So that makes a lot of sense. I want to just follow on with one sort of dual question, which is, you mentioned the DPIN as your kind of initial customer base. I'd be curious what conversations you're having and really how strongly they're signaling this as a need and a need that they're willing to pay for, or how that would work. And then as a sort of semi-related, have you been getting any concerns from the validator network for revealing their positions publicly as part of the protocol? Maybe it's not actually related.
Yeah.
Two questions.
Yeah. Yeah, so I'll try to provide three answers. So the first one is like just to follow up on the previous one. Yeah, like initially we're using just H3 buckets or like indices as how we represent positions. All the stuff you mentioned around like the complex polygons, like we've seen other folks doing location stuff, like try to bite off too much, and then it's too big of a problem to tackle. And so we don't want to do anything like the Polygon membership. We are
No need
just
yet.
distance. Yeah. Way too complicated for us to tackle that. Just like a location that's an H3 index, and then like a yes or no, are you in it? Like essentially that's the only good we aim to provide. On DPIN customers, I'd say we have like a number of MOUs and initial conversations. I'd say TBD, like once we get the test net like actually live and running, right? I mean, that's really when the rubber hits the road, is actually running it in practice and seeing how much people use it. So I'd say initial conversations look promising. I'll have to update the site with a number of these like logos just to show like the folks we're talking to. But basically, this is a problem that both VCs backing DPINs and the DPIN projects themselves understand. It's not really applicable to some sectors in DPIN as much, like AI. Doesn't really matter. Compute doesn't usually matter that much. It's more around sensor networks or like physical hardware. Like that's where location becomes more important. And then I think, so what was the last question? I forgot your third one.
Just the concerns that validator nodes have doxing their locations.
Yes, actually, so the ability for us to do like real geofencing is sort of controversial, right? And so it's like because like one of the real benefits of crypto is sort of trustless access to like high quality financial products for anyone around the world.
Global, yeah.
And like that's actually a really important mission. And so I'd say like that, the actual geofences and things not part of the protocol. That's something that folks could build on top. It's the same with the location, where if I'm signing a message proving that I'm in a specific location with a really high value key pair, like that's an incredibly dangerous thing to do because you've just basically put a big target on your back. And so the testnet isn't going to have this on day one, but one of the key things we aim to do is to obscure that with ZK proofs. So that from the perspective of a consumer, like you don't know what the geofenced region is, you don't know where they are. All you know is like the set membership. Are they in or out of this distance bound? Right. And so that way, the folks reviewing and auditing the use of the protocol can't figure out what your location is.
So you mean kind of abstracting it to the level of some much less precise, like you're in the H3 bucket of France, but that's all I can say, but I know you're in there?
Yes. So yes, I mean, thankfully, like the initial resolution is not going to be small enough to provide like a real security issue. But like, let's say we get down to a meter scale, right? You really don't want to pinpoint a high value key pair to within a meter. And so that's where, like, rather than just displaying an H3 bucket directly on chain, it would be like a zero knowledge transaction. So you don't know what region they claim to be in. You don't know like exactly where they are in it. You just know like this DeFi protocol required membership in an unknown region, and they said yes, we're in it, and that's all I can see from the outside.
Yeah, I don't know how deeply you've looked into the ZK Maps code base, but they've done some work on that with um, private positions inside of public polygons, as well as private positions inside of private polygons. And that's irregular polygons, limited number of vertices, yeah, they've done a fair bit of thinking on that, and it's wild stuff. And you're right, it's a bit scary, but
Yeah.
I think it's inevitable. And the way I kind of frame it in my mind is we we live in a world with borders. We live in a world where you are matters. Ethereum and blockchains generally are this incredible kind of graduation into cyberspace and the ability to have global access for the people that have the ability to kind of navigate the technical complexity, but it's still global access. And now the question is, how can we thoughtfully reintroduce borders onto the internet? Because where you are does matter, and people in local communities should have more of a say over what happens in their local area than people a long distance away, for example. There's a real value proposition to have location-based services. Democracy is a location-based application.
Yep.
So
Yep.
anyway,
it's kind of funny.
framing
I
issue.
wanted to see, I think Marcus had some comments and questions.
Yeah, no, I mean, though I was liking the way that was going, that about democracy being a location-based service, and how yeah, I guess that I have a number of thoughts about this. I have a question, but there's also a number of comments, because I realized I didn't introduce other areas of my background. The you touched upon helium versus the helium network, proof of coverage, but providing as a way to, I guess, could be providing vocations. I mean, I was wondering if you could sort of address that a little bit more, though I haven't looked at some of the more recent helium-based things. And then the two other items, I mean, I'm trying to brainstorm right now about it. In addition to blockchain, but the main thrust that over the years I've done with the OGC as a member, has been actually for Internet of Things data exchange standards. So coming up with an API or a way for IoT devices to exchange data, sensor readings, location. And one of the sticking points has always been sort of, the authentication, an authorization. And, you're dealing with edge devices, and how do you verify this item? So it's how to incorporate that into the standard, how to leverage something else, how to hook in to something else has been an ongoing discussion. So that's one thing that sort of fascinates me about this. A second, which is ironic, I supported the FAA for about 5 years on one of their their flight data publishing systems, one of the large scale. They're publishing the squawks of aircraft every 6 seconds, everything in the air, into this huge pipe of a data stream. But being able to you can falsify ADS-B data very easily. And I know that there's been some efforts to, what do you do about that? How do you deal with it? Even right now, I actually, during this call, for my 4-year or 5-year-old drone, I got one of the remote ID items that are required by the FAA and a lot of the other different national flight services to have on your drones, just to relate, who is that in the air, and go tie into a database. But there are a lot of angles that this could be utilized or leverages, or technologies such as this. So I just wanted to throw those two things out. I'm sorry, but but about helium,
Yeah.
if you can comment on that.
Yeah. On the second point, totally agreed. It's like a location proof is a different market good than a location measurement. And I think looking at like how GPS was adopted ton of initial military applications, but it expanded to all these things you couldn't have predicted at the beginning. And so I think location proofs could be similar, where like drones and ADS-B. Like that's not something I would have initially thought of, but it makes perfect sense. Like, okay, like aircraft are pretty high value assets. Like it's one thing to pretend to be in a location, it's another to know that they're actually there. And so that could be like a very interesting application. On Helium, I was just talking to Frank yesterday. He's the CEO at Nova, and then Noah Bai and the other folks at the foundation. And so this is the kind of problem they've tackled as well for years. You know, the approach they were taking was more around signal strength because they have essentially regulated hardware, trusted elements. And so, you know, they have limits on like, well, you can use an 8 dBi antenna and that's it. And so then if you measure the received signal strength at a certain distance, you can get a pretty good estimation. Like there's some path dependency and terrain stuff of like how far away the other Helium device is. But even there, right, like people can cheat that because you can just use, well, you can use a 10 dBi antenna. Or like you can have these little clusters of Helium hotspots and you pretend that all of them are in Saudi Arabia and none of them are, right? And so then they're all like consistently messaging each other. And so it's kind of a difficult problem. And so that's where like, I think at the end of the day, like that's kind of our view is even if we sacrifice some accuracy, like we have to fall back onto stuff that can't be faked. And like the speed of light, if there's anything in this world that I know people are not going to get around, it's that. And so like that's our take is like there's still room. There's still a need for like a more trustless way to verify where things are. I had a question. I saw a comment here from Carson Farmer, and he said, we're Textile plus Basin leveraging data locality for this exactly. We'd love to hear more about what that is.
Yeah, sorry about that. That was back when you were talking earlier about sort of the idea of subnet infrastructure. So Basin is a object storage style API and like decentralized network of storage providers who accept inputs, you know, any type of data, and we're using data locality, basically something somewhat like regions in a S3 sense, to leverage the sort of locality of the data so that you can do much more performant queries locally. And then, but we use a subnet architecture, so you can still reference data in other regions. It's just that it'll end up being slower to get your sort of like results and proofs and things like that. And yeah, so when we do it that way, you can kind of like increase the throughput of your network significantly, because, you know, in our simulations and in our like actual experience with users, a large percentage of the time, people are like writing and reading data for a particular region in a geospatial sense, or just like in general from the same buckets most of the time, and very rarely actually referencing, you know, data that's outside of their original region. So yeah, just taking advantage of speed of light in that sense. But we do have a big problem of just being certain, you know, it'll eventually be a fully permissionless network. So being certain that when a node provider says, oh yeah, I'm like, let me join this region to support the data in that location, that they're actually in that region. Because they can significantly degrade the quality of the service if they say they're in North America, but they're actually in, you know, somewhere else. Yeah, that was what that was in reference to.
Got it. Yeah, and that makes perfect sense. Like a CDN, you know, it's funny because like any kind of in cyberspace, we get away with like pretending that distance doesn't exist usually. But then like once you start to hit these performance limits, like we're subject to physics at the end of the day, and you have to like just deal with that and like build in recognition of that to get the scale you need sometimes. So that makes perfect sense.
Bill's got a question.
Yeah, so I put this question in the chat, but at Sorge, we deal with like data locality questions all the time. One of the things that we do is we try to prevent too many storage node operators being in the same place, right? Because that's a risk to our network, is if they all go down, then the data goes down, right? If half the network is really run by the NSA in some data center somewhere, and they pull the plug one day, that would be a bad thing. So we generally use like IP blocks as the way that we kind of segment that data. I mean, we would love to do something better, particularly when it comes to data sovereignty laws, right? So GDPR is probably the one that we all know, where you can't store that data outside of the European Union. And so we, having a decentralized storage node base, we have to understand these laws very precisely in order to be able to work with them. And in some places like Europe, we believe that we can say we're doing the right things according to the law, but in other places the laws are not, they don't have exemptions for encryption and whatnot. So the data sovereignty space is needs this a lot. And happy to talk to anyone after this about StorageA's use cases. I don't know that we're looking to change anything at the moment, but certainly we can feed into your thought process and the patterns you're trying to solve.
Yeah, interesting. Yeah, I'd love to connect and like see how you're thinking about it. And it seems like data sovereignty is one where like the resolution required is relatively low because it's on the order of jurisdictions, right? Where you're like either in the EU or you're out, and you almost don't want to know beyond that.
That's true, but proxying is the thing that we deal with all the time, because when in the world of computers, things you can't change is how much electricity costs in an area, right? And that the fixed cost of that scales very linearly, while bandwidth doesn't scale linearly. It's basically the only cloud service that scales exponentially. So you can get a gigantic pipe somewhere and send that data completely across the world. And so I'd really be interested in some proof of locations if they can wrap other protocols, because that's really the thing. It doesn't matter if you've got a proxy sitting somewhere, it can do the proof of location part. And then all of the real work gets done somewhere else. That's really the problem that we see in our network, is people just send proxy data all over the world and try to get past our kind of GeoIP filtering that way.
Yep. Yeah, so a couple thoughts. So what Proximum is measuring is the location of a key pair, right? Because it's like device agnostic. And so can you evade the system by putting the key pair somewhere else? Yes, but it's not like a VPN, right? Where it's a dumb pipe and you're just shuttling data through it. Like when you put a private key on a different server, it's like that is a much more trust sensitive operation, where if there's like any significant like assets held by that key, you're basically you're just asking to get stolen from. So it's like there's a little bit more of a crypto economic incentive not to put the key in an incorrect place. But in terms of now I'm thinking about this. So I'm trying to think from an analogy of like Filecoin sealing and unsealing, is there's probably a good way with like certain types of like hashing or encryption of your data to verify not just the key pair, but the presence of a specific piece of data at a specific region, right? So if you said like, hey, here's this very large, I'm just like spitballing here, but here's this very large, like 10 gigabyte record. Okay, I'm going to choose like a specific position in that, and then I'm going to demand that that is the thing that is sent around to adjacent Proximum nodes, right? If you're not holding, sort of like data availability sampling, if you're not holding the whole piece of data there, like that's a proof you wouldn't be able to complete. Because, now let me think further about this. Because you could require basically zoring it or something with a nonce that was generated by those randomly selected 10 beacons. And so again, if you're like VPNing into this or using a pipe of some kind, you're not going to complete the process in time.
Yeah, that makes sense. Yeah, so just things to think about.
Yeah.
Awesome.
Yeah, that seems possible.
I don't want to cut off really good discussion, but we're a few minutes over the hour. So I know we'll probably start winding down. If there's any like last final quick comments or questions, we can throw them in. But I just wanted to say, rather than having a big discussion about like what a potential name or rebrand of the OGC group that we want to bring together could be, I'll just throw out there the idea of something like the Decentralized Geospatial Web Working Group. It's not as catchy, doesn't tell you that it's about blockchain. So I'd love to hear people's thoughts about that. It is more inclusive, more encompassing, but I'm open to kind of suggestions. I just kind of throw it out there as like an idea that could be riffed on, or if folks really like to have blockchain or distributed ledger in there, then I think those are other kind of nice things to think about as well.
I mean, I guess this is my first time here, but obviously I've been involved with the OGC for a while. I guess I think you need something along the lines of blockchain and distributed ledger, or something related to that. So you don't want to expand the name such that it's overly complex. And so, I mean, that is perhaps an issue now, and then adding on more could be tricky. But at least let me just back up. The rationale when it was first, the working group in the OGC side was first created, was to say blockchain, but not it only be about blockchain. It's more about distributed ledgers and trying to incorporate more items. So, but blockchain was in there because otherwise most people outside would not understand what it's about. A lot of the OGC is about there are different working groups about distributed this, distributed that. So having it just that is probably too much. But modifying it, I don't know. There's a I don't think you can drop it completely. That's my 2-minute explanation that I could just say. I don't think you can drop blockchain and distribute. You need to have something in the mix to talk about the talk about the ledgers, talked about the crypto, etc. So
sure,
but I'm not sure what that exact mix is.
Yeah, we can just something we can riff on. I mean, you can even bring it up at the next meeting in a month, but perhaps something like decentralized protocols and blockchain technology or something like that. That's it's we're all iterating on the same things, but something that makes it less complicated but also inclusive, I guess it would be the gold standard. John?
I'll just chip in and say, I think, Marcus, your point is definitely sound. Like clarity and kind of orienting people, especially people who aren't necessarily so familiar with this whole wild world we all have immersed ourselves in, blockchains and smart contracts and da-da-da. I think on the other hand, Taylor, I think the idea of expanding the scope to not be exclusively, I mean, it's not necessarily exclusive if it has blockchain in the title, but some indicator that this is actually quite a lot broader than just blockchains. And in fact, a lot of decentralized geospatial technologies should and will never go anywhere near a blockchain because it inherently needs to preserve users' privacy or give them the ability to selectively disclose things. A lot of these decentralized storage systems aren't actually technically blockchains, but are still really relevant to the work. So I think the impulse to kind of somehow signal that this is quite a lot more expansive, and that these principles of decentralized design as applied to geospatial data technologies is a really valuable kind of area to investigate, and that's the scope of what the working group is looking at. I would support that, definitely.
Good feedback. Awesome. Any other final kind of thoughts, questions, or comments? All right. Well, it's been an awesome, lively discussion. Thank you so much, Chris, for coming out and speaking. And we've got the next one scheduled for November 7th, 1 p.m. Eastern. Hopefully, we'll see a bunch of you there.